Exponential growth and decay. Exponential growth can be modeled with the function y equals a times b to the x power, where a is the starting amount when x is equal to 0, x the exponent, and b is the base, which is greater than 1 because it's a growth factor. Now, this formula right here is the same formula we used yesterday. Okay? So if we take a look at the sample problem, can you start reading up here, Sophia?
Since 1995, the basic was expected to usually have selected a new and a producing slot. In total, in 1995, the factory will average upon $60.
Here we go. So if we look at this first equation, write an equation to model the cost of hospital care. Okay, so we would say y equals a times b to the x power. We know that a is what? The starting amount when x is 0, right? What is b? The growth factor, the base. It's the base, which will be greater than 1. It's a growth factor because we know from what we read that it has increased, therefore it's a growth. So we can say x will be equal to the number of years since 1985, and then we can say y would be the cost of the hospital at different times, right? So depending on what x equals is the different times, the different years when. But the cost at different years. So what about A? A has to be what? The starting amount, the initial cost. The initial cost, when was the initial cost? In 1985, right? Do you remember what that amount was? 460. What about B? It's the growth factor. So B is going to be the 100% plus the growth, and the growth is what? 8.1%. This is equal to 108.1%. Now in order to use this percent, we need to change it to a decimal. So 1.081. Can we use this in our equation? How would we set this up? Y equals, what was the initial amount? Times to the x power. Yes, Pete. The reason we add 100 is that every year it's increasing. So the full amount that it increased the year before would be the total percentage, which would be the 100%. Yes. Yes. So whatever percent they give you, you add 100 when it's a growth factor. That means when it's becoming more. We're going to get to that example. Can we use this equation to answer the next question? Use your equation to find the approximate cost per day in 2000. So how many years from 1985 to 2000? 15 years. So what's changing in the equation we already have? I'm sorry? The exponent. The exponent in this case is going to be what? 15. 15 years from 1985 to 2000. So once we calculate this, I got 1,479 with 60 cents, and we can even round this to $1,480 per day. Okay, take a look at this question. Suppose your community has 4,512 students this year. The student population is growing 2.5% each year. Write an equation to model the student population. What will the student population be in 3 years? This is the solution for Check 2 Understanding 1 on page 438. When a bank pays interest on both the principal and the interest an account has already earned, the bank is paying compound interest. An interest period is the length of time over which interest is calculated. So, compound interest is paid on both the principal, I'm sorry? Thank you. Is paid on both the principal and the interest an account has. An interest period is the length of time over which is calculated. So let's say, take a look at this one. Suppose your parents deposited $1,500 in an account paying 6.5% interest compounded annually, once a year. So annually means once a year, when you were born. Find the account balance after 18 years. So here we go. So here we go. So this is the result to example number 2. So let's say we have an exponential decay. That means y equals exponential decay. Y equals a times b to the x power, where a is still the starting amount when x equals 0. B is the base. It's still the base, but now it's between 0 and 1 because it is the decay factor. That means decay means it's becoming less, right? So for example, like here, milk consumption. Since 1980, the number of gallons of whole milk each person in the United States drinks each year has decreased 4.1% each year. Decrease, decay. In 1980, each person drank an average of 15.5 gallons of whole milk per year. Write an equation to model the gallons of whole milk drunk per person. So let's start setting up. So originally, how many gallons did people drink? 16.5 gallons, right? How much has it decreased? 4.1%. So B is going to be equal again to our 100% minus 4.1%. Why minus? Decay is becoming less. So this means 95.9%. We have to convert this to a decimal, so 0.959. What about x? What will x equal? The number of years since 1980, right? So what would my equation look like? Times 0.959 to the x power. So if I want to know the approximate consumption per person of whole milk in 2000, how many years have gone by? Because this was the consumption in 1980. So 20 years. So what do I need to add to my?
Take out the x and put one.
The exponent is now 20. And so now people consume 7.1 gallons per year.